Okay, there you go.
Yeah, thank you.
So we're going to talk about API security. Quinn asked earlier, who knows what an API is? How many hands went up? Could we do hands again? Okay. Of everyone who knows what an API is, how many of you have worked directly with APIs, like actually consumed them, built them? How many of you worked on the security side of APIs? Okay. And have any of you actually done any like hacking of APIs, whether white hat or black hat? But okay, a few hands up on that one. Um, APIs, it's kind of a statement that's kind of well done. APIs are everywhere, but if you're not familiar with what APIs are, they're, well, I guess does anyone want to tell us all what API stands for? Maybe? Yeah, application programming interface. Simply put, they're a way to like abstract away accessing data. So if I have, a SQL database, DynamoDB, a Salesforce backend, I don't really have to care what all of that is. I just know if it's like a SOAP API, REST API, GraphQL, gRPC, whatever it might be, I just work with that protocol, and it becomes really easy to interact with that API. So APIs, when we talk about them, that's application programming interface that's been around for a long time as a term, but what we're referring to are specifically web APIs. So those are the things that when you, well, there you go. When you go like on your banking app and you log in and you're looking at your balance and you're doing like an ACH transfer, when you go to delta.com to book a flight, things like that, the underlying framework that those mobile apps are using, that's all APIs. So from that perspective, APIs are pretty important to the web today. Um, Almost every web application now is API driven as well. It used to be I'd say most of the people in this room are old enough that, when we all started using the web, you'd see it like, load a little bit at a time. And every time you click the link, the whole page would reload. Um, but, if all you've experienced is the web where every time you click things, it just kind of magically appears and the screen doesn't refresh, that's because everything's underlying that is API calls now. So it's not actually reloading the web page, anything like that. So APIs did some really good things for us in terms of uh, what do you,
Just moving things around.
interoperability, the ability to easily interact with data, the ability to make our websites more responsive, things like that. So that part of it was great. Um, the bad part is as we got into everyone adopting APIs, me, there you go. So I tell you, one of the biggest problem with an API is, typical expectation 100. So I guess how many folks in the room you work for security? You have to ask your developers what APIs we have. There's not really a central location where you've got every single API documented. I mean, that's been a pretty common thing, I'd say. Um, I actually worked as a software developer for like 8 years. In the last company I was at, when I joined, every time I needed to interact with an API, I needed to find the documentation. It was, go ask Bill at the end of your table. He's been here 20 years. He knows where all the APIs are and how to interact with them. Great form of documentation, makes it really easy to do things like blue team, red team testing. It's a problem. So there's lots of APIs out there. There's lots of APIs we don't know about. There's lots of APIs that, it's a V1 of the API, but we're running version 5 of the API. V1 was a SOAP API last updated 5 years ago. It's still online and on the web. So things like that represent a really big problem in terms of just attack surface and ability to implement any kind of, I'd say, rigorous security practice. So that's the first problem. The second is, uh, I'll say the second is really the developers themselves. In a lot of ways, I can say that because I was a developer. So, but the biggest issue we see with APIs are really design problems. So we do hear about 0 days. We hear about like the log4j incident where there was a command injection 0 day. Although even that, if you dig down into it, that's a developer made a mistake somewhere. They weren't doing rigorous enough testing. So APIs, we are making a lot of mistakes with them. And today it's easier than ever. You have old school tools like Burp Suite, automated tool sets. You can just point at an APIs. You can just, in your browser, right click inspect, browse them. I mean, Did anyone in the room hear about like the Alabama teacher social security link? No? Okay, so Alabama, they put up a website and it turned out if you right click inspect and looked at the underlying traffic, you could see the social security numbers for all the teachers. Yeah. That one's interesting because it was actually someone fairly ethical who found it and reported it, and Alabama threatened to basically put them in prison for finding it. They called them a hacker. Yeah, be careful when doing like any kind of freelance bug bounty work, I guess. So like just inspecting your browser, we had one of our customers, so we host like capture the flags and things like that. They work for an energy company. They went back and did the same thing and started browsing their own website with just like the inspector on, and they were able to find an API leaking data and submit it internally to their bug bounty program. Like it's really easy to find these things with just a Chrome browser, right click developer tools, inspect. You can see all the API calls being made. And then you hear from a lot of developers like, oh, well, our mobile app, you're not going to be able to inspect those APIs because it's a compiled APK or something like that, or IPA. I just throw a proxy up on your local network and you can sniff all the traffic. It's really easy to see. It's on the internet. It's easy to poke at those APIs. So there's a really big problem with all of that. And ultimately, I guess raise your hand. Are you familiar with OWASP, the organization? Okay, great. Does anyone know the OWASP top 10 of API security, or at least the number one? Anyone want to volunteer it?
You get a stand name for that.
Oh yeah, okay. BOLA, what's the stand for?
Broken object level authorization.
All right, so broken object level authorization. So that means you're able to access data that doesn't belong to you. For example, Delta had one. I think it made the news. So if you read about it, they had one where you could go in and essentially transfer other people's sky miles from their account to your account. So like that's Ebola. They're able to access data that doesn't belong to them. And I guess authorization is really complicated in APIs, especially when you think about, banking apps, stuff like that, to where you're going to have authorized users, you're going to have big company accounts, things like that. It's really difficult. But I guess on that note, the other question we were going to ask. So BOLA is broken object level authorization. Who knows the difference between authorization and authentication? Go ahead.
So authorization, first start about authentication, which means you use signing and password that you get into the door, and which means you're authenticated. And then authorization means do you have access to certain things to.
Yeah, exactly. So if you didn't hear him, authentication is it's what gets you in the door. It's when you showed up to the Red Hat building and you signed in, that's your authentication. Authorization is if I wander around the floor and find the server rooms, I shouldn't be able to open the door and start monkeying around with the wires. Authorization is what you're allowed to do once you're in the door, I guess. So that's the number one problem that OWASP has identified. I'd say that one's pretty obvious because there's huge implications when there's an authorization problem. You can access data that belongs to other users. But believe it or not, the example with the leaked teacher social security numbers feels like that should be really easy not to screw up, where developers shouldn't be, spewing out data like that. It's actually number three. It's extremely common. I think a great one would be, has anyone been on a cruise? I've never been on a cruise. You've been on a cruise? Okay. These cruises are interesting because they all have the mobile apps now that like control everything you do on the ship. We have a customer, I won't specify which cruise line it was, but like one of our immediate findings when we plugged in was if you were going on an excursion, the excursion leader needed to be able to like see your name and like first name, last name, phone number. They had an API completely unauthenticated where you could see your first name, last name, phone number, email address, which birth assignment you had, what your home address, like all the personal information you put in was just out there on the world. So it's like really common. It's really easy to find. Then I guess the other big thing now is anyone playing with like MCP servers and things like that, and then creating agents. That's going to be a really interesting world where people start like sticking agents at APIs to look at them. So APIs are They're very vulnerable. Lots of it is just due to developer mistakes. They didn't add authorization. They didn't add a quantity check. So if if you're ever placing an order on an e-commerce store, see if you can change the quantity to a negative and if they'll put number on your money back on your credit card, because I've actually seen that happen. So these kinds of issues, they really boil down to developer issues. And that's because when we kind of look at the anatomy of an API, so there's really, I'd say today there's three common types of APIs. SOAP APIs, and that's just because they're a legacy. They've been around forever. You may have worked with a SOAP API, maybe not, but REST APIs are the most common. So almost everyone's doing everything with REST. And with REST, you expose resources, and then you expose kind of operations you can perform, like get for retrieving data, post for creating it, put for updating it, patch for also updating it. And some identity kind of differences there, and delete for deleting data. What you may not realize is, as a security practitioner, and this is something we find a lot, when you go talk to a developer and you ask them, tell me what APIs you have, they're going to come back to you and say, well, I have this customer API, and here's my spec for it. Now, what they're not telling you is that customer API, the spec is 5 years out of date. They haven't updated it in a while. And they've added, I don't know, 20 endpoints to it that they didn't put in the specification. So if you're going to go do any kind of pen testing, you're going to miss those. And every single one of those operations and endpoints on an API, it's routing to a different set of backend code. So even if it's all running as a single Python application, there's going to be a function for every single one of those operations, which means there's kind of a unique point at which you can exploit that API. Everything from basic command injections, which you might be used to with like Burp Suite, where you have like the Python pickle error or deserializing things would let you execute arbitrary code on the VM, to what we were already talking about, where they didn't enforce authorization, you could change the inputs, things like that. So it's really difficult to catch these things because there's going to be thousands of these endpoints and operations that you don't know about. If we jump forward, I think we can skip that one. And I'm going to go, all right, here's the OWASP top 10. We talked about BOLA, and then the broken object property level authorization. So if you're interested, this is BOLA, or the OWASP top 10. There's some great resources on there. So they have some like capture the flag environments you can spin up. So if you're comfortable with like Docker, you can go run a couple Docker commands, it'll spin it up and you can play with it. But if you're not familiar with OWASP, so not every hand went up for that, they're kind of an open source foundation. What they work on is just kind of categorizing what the top threats are. They are cross organizations. So some of them are going to be with companies like Akamai, Red Hat, but some of them are also going to be with, the like the Nissans of the world. So where they're building APIs for their customers directly. So if you're interested in that, I would definitely encourage you to go look at that. But I'm going to jump ahead to this one. All right. So we've talked about kind of a lot of the problems we have, limited visibility. So you don't know about what's out there. There's limited observability. So most organizations are not actually monitoring in real time what's going on with their APIs. They might be monitoring the logs, pushing it to like a Splunk or something like that. They might have a WAF that's monitoring for things like command injection, SQL injections, but they're not looking at every payload that goes through that API. They're not looking at how the users are actually using that API. Typically, just not something that's done. The runtime controls, similar concept. There's some organizations do this very well, where they have highly automated processes where when they deploy it, it's guaranteed to end up on the gateway, things like that. But most organizations, it's kind of like, I mean, at my last place, I paid a ticket, go to the knock and stand behind the guy while he would deploy things for me. And we test it in prod, right? That's kind of the developer mindset. And then feeding into that, minimal testing. So if anyone familiar with SAST, SCA, that kind of standing process, great. So That is static code scanning or source code analysis type of process. You're looking at you including vulnerable packages, things like that. Very common. But the reality is almost no one's doing DAS testing. That would be things like what you see a red team or blue team doing with an API. You might have heard like the pen testing term. If they are doing it, they're maybe doing it twice a year, but they're not doing it on every release of the app. You can miss a lot of stuff when you're not testing an API by actually calling all of the endpoints and testing, does my authorization actually work? Am I following my spec and not returning social security numbers? Those are important things, but we're not really testing those ahead of time. So that's kind of the current problem. The solution is I'd say Akamai API security solution, but it's really more just like if you're going to do API security, this is kind of what you need to do. Discovery, pretty obvious. Build an inventory of your APIs. Don't rely on that being a human process. If you have to spend 6 months interviewing your developers and begging them for specifications, by the time you're done with that, your inventory is out of date. So it needs to be a fully automated process. Posture management is the idea that you should be monitoring all your APIs in real time. You should be making sure they actually conform to the specification. So look at the data that actually flows through them, look at what the developer created as a spec, make sure they match, that kind of thing. And then runtime, I would say runtime's an interesting space because it's really hard to tackle. Like, think about it. If you're trying to protect, let's say, just the negative quantity bug, there's a company we worked with who they sell beer, and it's all B2B, so they don't really do B2C, but their APIs were on the internet, and someone figured out they could place negative quantity orders on their API and actually get money back on the credit card. So it was a really interesting kind of discovery. Part of it was they're like, well, these aren't public APIs. No one knows about them. It's on the internet. People are going to find it. So how do you protect against something like that? Like detecting that, oh, someone sent a negative quantity field because, Akamai, we're a WAF company. A WAF can't do that. It's not a command injection, SQL injection, anything like that. So the idea behind runtime protection, there's multiple products that do this. We do it as well. We build machine learning models of what normal looks like for an API. So we learn over time, hey, that field's an integer. It's always a positive integer. It's never a negative. Users come in and there's like a one-to-one user to resource access going on. So if someone comes in and accesses, 10,000 different accounts, that's a problem. So I think machine learning, LLMs, those kind of models where you learn what normal is for an API and start inspecting every single payload that goes in, that's going to be really important. And the last is just testing. We already talked about this a little bit, but it's instead of doing just code scanning, you need to shift to actually testing every API endpoint by calling it and testing things like bolas, testing things like putting in that negative quantity and seeing how the API reacts. Does it get to 400 bad requests, or does it actually process it? So that's the Akamai API security solution. That's what our product does. Again, kind of, I will say this is a new deck. I haven't gone through it before. That seems to be a repeat of the last slide. So I will jump past that. Yeah, I already talked about it.
Question on stoves.
Yeah.
Can you explain how you will install these APIs?
Yeah. So there's a few ways to do it. I'd say the most common practice right now is traffic observability. So that would be companies like, Wiz does it, so they'll be in here later. They'll talk about it. They have agents you can deploy that can kind of look at traffic. We do it by tapping into like your WAF, your API gateways, your load balancers. If you have an on-prem data center, there'd be like a layer 4 tap in there. The idea is just to get visibility into the raw traffic. That's kind of the first step. The second one that's becoming really popular right now and is kind of taking off is API from code. So that's something we've recently introduced into our product. You'll start seeing that more. And that's really just kind of everyone's putting AI in everything, but LLMs are actually pretty good at this. So essentially what you do is you take all your developers' repos and you run them through LLMs and essentially say, what APIs are in here and what endpoints are there and how are they structured, what data is coming through it. They do a pretty good job of that actually because I don't trust code that most LLMs write, but I trust it enough to read the code.
Generate a bomb from all that.
You can generate a bomb out of that. That would be something like an SEA SaaS would probably focus on. But what we're generating are like Swagger specs, GraphQL interest or GraphQL schemas, SOAP WSDLs, things like that to get a view of what's in there. Yeah. And then the last one is reconnaissance. So that is really, anyone familiar with the term OSINT? Yeah. Okay. So less hands went up that time. Open source intelligence gathering. It's the idea of you just kind of go out and crawl the web looking for things. There used to be some really fun things you could do in like the original days of Google where you could find like unsecured webcams, things like that. But yeah. So automating that process, we've got tools today that'll like go out and scan Postman repos, things like that. It was really interesting. We found one with a vehicle manufacturer who their QA team had created a Postman workspace to work together, and they made it public, and they had credentials for QA, prod, dev, and staging all in there, like client ID and secrets for generating tokens. And like you could just go ahead and click request and it would generate the token and you could do whatever you wanted in there. That's actually is anyone familiar with the SiriusXM BOLA that happened? That's actually a really good BOLA example. So if you're interested in the kind of things that like a BOLA represents, does anyone have an app where you can like turn your car on remotely, turn on the engine, turn on the seat heaters? I guess like Teslas, yeah, they do that. Apparently you can drive them now through the API basically, but what's that?
It's scary.
Yeah, well, there were 7 vehicle manufacturers. I can never remember the list. Let's see if I can do it this time. It was Infiniti, Nissan, Honda, Hyundai. I don't remember how to pronounce that correctly, but what's it? Was it GM as well? Maybe? Or and Range Rover, I think, was one of them. They had actually all outsourced that process to SiriusXM. So they put SiriusXM in the car, and then SiriusXM could like control the car remotely for you, including pinging like its geolocation, things like that. Uh, Anyone know what a VIN number is? Yeah. Do you know where the VIN number is on your car? Yeah, it's on your windshield facing out. The API they designed, you could just pass in a VIN number. Didn't matter if it was yours or not, you could control the car.
Wow.
Yeah, that's a really fun example. So if you go look on the web, there are hundreds of examples like this. I mean, frankly, it makes you want to just like go cache only and get off the internet a little bit, but you know. Yeah, you could pull up your latitude and longitude of the vehicle, you could unlock the doors, start the engine, things like that. I mean, in my city at least, they were just taking USB drives and jamming it into the key of the Kias and turning it, and it was working fine. So there was no need to be a sophisticated hacker to do that. But yeah, so that's long tangent. That's what discovery looks like, plugging into code, doing external reconnaissance, and doing APIs from code. But I think ultimately it's really the biggest thing is going to be people and process. Like, obviously, we sell Akamai API security, but you can't just buy a tool and it's not going to just solve your problems. So everything boils down to people and process, having the processes in place where developers can't just go deploy something. I mean, my first job as a developer, I ended up deploying something where I couldn't get permission to put it out on the firewall. So I created like a reverse proxy tunnel so that I could expose an API, and they never found that. I shouldn't have been able to do that. I mean, developers, we're going to do what we're going to do to get the job done. So you just need to have people in process. And on the security side, it's also about not being, I'd say, obstructionist, because if you're in the way, they're going to go around you. So having the tools and capabilities to work well with your developers becomes really important. Um, any questions about discovery, posture management, runtime testing? No, you can deploy SaaS, hybrid, or on-prem.
Get the new threats embedded.
You either have to install software updates, which means you're now managing your software stack. So don't go 5 years without updating no name, especially because we have APIs in our product too, which, there's going to be mistakes in there and security vulnerabilities that get patched as well. So, I mean, the reality from a security perspective of an API is you just have to understand there will be vulnerabilities. There is nothing you can do to prevent any vulnerabilities at all. And even if there's no vulnerabilities today, a year from now, a package that was secure may not be secure anymore. It's just the reality we live in. So you need to build those people and process around it and have strong tools in order to help you with that. Yeah.
So I've been in tech for some time now, and one of the major problems that I find is whenever anyone wants to share data, any partner, they'll be like, oh, you have the system, can you please expose these APIs? Let me consume all the data, right? Industry practice that is very, very common. And I do see that, like, that is one of your top things to catch as well, right? Like API inventory from scratch. So even if I use the solution and this ecosystem, how did you sort of equip me to detect things that are being shared, like, outside, the required privileges or like NTK or like, I think we can.
Are you talking about if someone's sharing, for example, like data that they shouldn't be,
Yeah,
or?
like, are there like automated things or other things that you're working on which can help, like, surface some of those things, like what you should think?
Yeah, the if anyone on this room didn't hear her, she's talking about how do we detect when people are boiling it down. It's like when people are sharing things they shouldn't, things like that, or even if they should, if maybe you weren't aware of it. Is that kind of what you're going for?
Yeah, but it's like, it's all in the layers of API, right? Like, I'm just gonna use like, PagerDuty has this API, right? And I'm gonna like use it to sort of get the data that I want, and then I'm gonna put it in Tableau, then I'm gonna connect to a Snowflake. Right, I have like my whole own ecosystem.
So you're talking about like third-party APIs being consumed, not necessarily you building APIs to expose your data?
Yes, exactly.
Yeah, that's a really big one, especially today. Is your company doing anything with AI? Because it seems like everyone is. Yeah. Yeah. Well, I have customers who they are still developing SOAP APIs. They haven't adopted REST yet because REST is too new of a technology, and they're just running MCP servers and AI agents. So I get what you're saying. So it sounds like the question's more about how do you handle like when you're working with other APIs, like someone has Salesforce, they build a workflow where they're moving data, out of Salesforce into Tableau, things like that. We call that third-party API detection, and that's done through agents. Is anyone familiar with eBPF? So eBPF is a Linux kernel extension type technology. Yeah, so essentially you hijack the SSL libraries, and that allows you to see all encrypted traffic between that application and the other API calling by having agents on that VM. That does require you to know where all your VMs are and things like that, where workflows are running, and stick agents on them so that you can get visibility to what's happening. And then I'm not an expert on it, but we have some products like Guardcore that are supposed to help with monitoring that kind of thing as well. So that maybe we're exploring, but basically agents that see encrypted traffic or how we're dealing with that. So we can actually see the usage of external APIs and what data is flowing through.
That's why I asked the question. I was thinking that, you already have solutions that you are sell to people that people are using this strategy.
Yes.
So did anything like have your solution really makes like catch like really interesting and cool stuff? I mean, you don't have to share like customer data, but just like generally over.
So yes, generally speaking, the two top things that we catch, I mean, there's a reason they're on the OWASP top 10. The top things we catch are broken off, well, really broken authentication, not authorization. And like data leakage. So one we found, they were moving into their Salesforce. It was like patient record information that had things like their actual results from medical tests and things like that. But the reason that one became such a big deal is there was another API that was exposing Salesforce's data. So they were putting that data in Salesforce. We can see them putting the data in Salesforce, and then we can see another API that was exposing the data in Salesforce as like an abstraction layer with no authentication on it. And so you could like actually through that like circular path pull like those patient records out. So you could like pull out someone's MRI scan through that API. So I mean we find things like that. Usually I will say most of what we're finding, it's not malicious, at least from like how it happened. This is not someone went in there and did a command injection and, you know, popped your VM and they came in and took it over, become an inside threat actor, started moving data around. It's really just people made mistakes and then someone found those mistakes and started pulling data out. That's the majority of what we find.
Yeah, I mean, it's not malicious by intent,
No,
but
not by
by
intent.
outcome.
The outcomes are very malicious. And when you have those class action lawsuits, I mean, the Park Mobile $1 settlement, I got my $1 settlement with Park Mobile.
But I think the last thing that I would add on
Yeah.
is, so if I use your solution,
Yeah.
and I'm like, just monitor the API traction, it's gonna be a better result than what I would get by using something like WorkSuite, right, setting up my own proxy. So it's gonna be more mature and evolved.
Yeah. And I think the important part too is it's a suite of tools at that point. Whereas if you go out there and build this yourself with the different tools, you can certainly do it. Not like you pretend there aren't tools out there that will let you do the same things, but it will be well, we have to build a burp suite, some postman collection, things like that to do testing. And then you have to get something that monitors the traffic so that you can baseline things. Then you have to figure out the discovery process. Then you have to get something that can scan your code and do like API discovery code. So the point is we're trying to take every aspect of what you need for kind of end-to-end lifecycle security for an API, from design time where your developers are still working on it, all the way to when it's in runtime and it's, you know, it's a 10-year-old API, but it's a single platform, single product. I'll start over there because that's what you can help.
So what is the next step? Like, how do you generate a priority list from this? From what I gather, I mean, do you look at any industry, you know, what is actually exploited?
Yeah.
Kind of prioritize.
So the question is, how do you prioritize handling these findings once you find them? So our philosophy is really framework based. So we support quite a few frameworks like NIST, PCI DSS 4.0, the OAuth top 10 of like 2023. There's a whole list of frameworks on there. It's quite a few, but usually we look at the frameworks and that lets us do scoring. But there's a lot you can do and a lot of things we recommend doing. So like, for example, Wiz is one of our partners. And so, okay, well, let's integrate with Wiz. And so now I can tell you, well, you've got this API over here that's leaking some data. It's something that could maybe be non-critical PII. But the VM it's running on is secured. And then this API over here, well, it's got all these Wiz vulnerabilities in it. And it's handling PCIe data. So like we'll do all that kind of scoring, rule surface. You really need to tackle this one first. From a runtime perspective, we take things a little differently. The idea we approached that with was Most security tools, when you look at runtime security, you're gonna have like thousands of incidents in your runtime security. It becomes pretty difficult to weed through that. So instead we build what we call the attacker view. So we take all of the individual incidents and group them into, this was one actor doing that. Here's the 10 different IP addresses they did while doing that. We use practices like how they're authenticated, TLS fingerprinting, cookie tracking, things like that in order to kind of figure out that that's all the same user. Not perfect, sometimes it'll get split, but better than nothing. And what that allows us to then do is say, well, this guy was generating noise, he was sending negative numbers in payloads, and he was, trying to access multiple resources and get 403s, things like that. And then we saw him start trying command injections and SQL injections, and then he went and accessed, 500 resources over here before the tool blocked him. So like it'll do confidence scoring and risk scoring on that. So frankly, pretty standard kind of approach there, but we do the attacker first approach rather than just a list of incidents. And then of course, we integrate with ASPMs and staging systems, things like that.
So are you trying to line it something like EPSS where you're trying to go for client potential exploit rating?
Client potential exploit? Yeah, so it's like we flag, here's what the risk would be if they were successful. And then we start risk flagging. So we have like internally trained models as well. So there's the models we generate that are specific to you. Then we have the models we've trained internally on incidents we found with other customers. It's not their data in those training, but it's help identify like false positives, things like that. And then we can give like confidence scoring on that. And then you can actually tweak things with your own risk scoring. Things like, is there PCI data, PII data that goes into it? We have some customers who they're like really tight with their AWS environments, for example. So everything is like an L1 environment or an L2 environment. It's been tagged. So we'll ingest those tags out of their AWS and do different risk scoring based on that kind of approach. So yeah. I'll get you next. Right.
I'm trying to reconcile the shift left security strategy with this, because it looks like this is more cleanup what has been done in the past versus stop doing it. And so that's what I was trying to understand.
Gotcha. So the question is about the shift left strategy. And that's really this last point, testing. So shift left, if you're not familiar with the term, it means basically tackle your security problems before they're in production. So if you're looking at the life cycle, move left on the life cycle. There's good reasons for that. For one thing, it's a lot cheaper to do it there because you're not wasting a ton of man hours pulling something out of production. So the way we're tackling that today is we have a DAST security testing tool. So we would definitely recommend you stick with your SAST and SCA tools and things like that. But we have a DAST testing tool as well that's designed to go either, kind of depends on the org, how mature they are. You can run it like a blue team where you're throwing it at like a QA environment, or you can put it in like a CI/CD pipeline. But the idea of what the tool do is, so the majority of the tests we built ourselves. We do have some like open source tests we've included, but it's designed to do things where in testing, it'll log in as user A, create a resource, then switch users to user B and go see if it can access that resource. It'll see if, oh, you've defined that there's a regular user and an admin user, and here are the claims and the JWT that controls that. I'm going to go log in as a regular user and see if I can do a put on the admin API, things like that. So the shift left would definitely be DAST testing and automating that. It's the idea that our recommendation was nothing should ship to prod without going through that testing. Transparently, but
I will add on one more thing because you're saying DAST comes on the next phase after design, right?
Yeah, that comes after design.
Actually starts with the design. Where exactly you are going to be looking at the API design, and you are going to work with the developers using the threat modeling techniques and all that, and you're going to be listing all the threats and risk and mitigating factors. Then you tell them as a security professional saying that okay, the design has got issue. You are going to be correcting at the design stage. then go and do the dash and classification. So it starts with your design, then you bring your threat model.
I'd say,
At the design phase itself.
I'd say one thing, it is really hard to get developers to do, and if you can get them to.
Yeah, that's,
You don't want to do it.
that's the reason every company has to go with security and privacy.
Yeah, but I'd say like, when developing APIs, for example, if you can get a developer to write the spec before they implement the API, for example, you can run it through like compliance and governance best practices, you can put it through linters, things like that. Really hard to get a developer to do that, they're gonna wanna just auto-generate those specs. So we found DAS to be the most common place you can get early, but we do actually have tools that if you're at the like spec design phase, you can also do compliance checking on that. I will say, like, transparently, getting full automation shift left is pretty difficult, just because it's the onboarding process. What I have found, if you're familiar, there's kind of the term DevSecOps floating around. It's the idea of you take like, it's been around for a while, it's not new, but it's gaining a lot of popularity. And it's largely because APIs, they're kind of, it's not very clear how to interact with them unless you spend a lot of time with them. So getting like a separate security team to do comprehensive testing becomes really hard. So I will say we have found the best success is when developers are actively involved in helping set up the security tests. And then onboarding something like a DAS tool and an automated pipeline.
It's the LLMs impact homes.
So far, I haven't seen anything where it's LLMs designed to do the testing, but I would imagine that's going to come. Only because it would be really easy to create like an MCP server that does API calls that you can then plug into an agent, you feed the agent your code repo. But I haven't seen it yet, and maybe there's some startup out there in stealth who's gonna come out and get acquired quickly, yes. So far today, I'm not seeing a lot of LLMs in that space. So maybe it's a good idea. Yeah.
So I have a question on this API implemented from traffic, so all the REST API is going to be running at the layer 7 here. Goes to app, from app, it goes to API gateway. So we have most of this API injection attacks are going to be covered with those two. But still, there are possibilities that there could be a sensitive data exposed after passing the traffic going to this controllers and all that. So what would be the best mechanism there as a layer of defense of the app and API gateway?
So you're talking about like actual runtime mechanisms that we're protecting against?
Yeah.
Well, I mean, I feel like the answer I have to give is a tool like ours, because we're integrated into those and we're part of the runtime cycle. And we can actually block attacks and things like that as well. So if we see, you know, hey, Michael just logged in and accessed, 50 different SkyMiles accounts.
That we can do it on API gateway itself, right?
Or gateway, WAF, load balancer, we integrate with all of them in order to do blocking. So that's what I would say. Highest answer, I think.
It's also about the time, right? It's about like when you decide, which layer you decide. That defines like how much time you have to respond.
Yeah, we already have WAF covered, and the WAF is the boundary layer, edge layer. Then we take the API gateway.
And I will say, like, a lot of the detections, when you're looking for things like detecting Ebola, for example, that's not something you're really going to be able to action on until after the API call is completed. So it becomes a bit of a game of, well, you might lose 10 records to this person, but you can then shut it down after 10 records and prevent 10 million records from being lost. And that's just because the pattern has to be established before you can even detect that there's an issue.
And it matters where you respond, like you can detect it on RAP level, you can detect it on API level, or you can have your own tools. This guy, which is like pulling logs from all of these places, plunk it, and then you can pull log. But it matters how fast you can respond. Because time is money and data is money. So I think it really is a broader question, but it is a very hard problem to solve. Like detecting errors, like for example, you make a startup and you have like 50 people working for you. You gave laptops and phones to everyone who works for you. Now you can see logs for one person who has logged in from their corporate account from two different geolocations, India and the US. Now that would obviously be,
We all get that detected on data gateway.
yeah, but like, how would you respond? Like, would you like fire that person right away? Like,
That is true, but that's what I'm asking, what exactly that tool is going to be doing after those 2 layers?
No,
Because we have a-
that blocking, absolutely doing.
yeah.
The thing like that, again, it's like, Steam is going to collect all the data. Yes. But it's not going to give you a immediate alert.
I mean, not immediate, but depending on how fast they can. Yeah. It may not be immediate in the next second, but,
Now that already,
You need to basically investigate more. You need to like figure out what other things are happening for them, why.
I think everything you're talking about gets back to the point of people in process where it's a very difficult and important thing to do, but, I'm sure afterwards, when we're all mingling and getting some drinks, we can have that conversation. But it's a long conversation.
I can have one question. Especially on the logging side, right, logging of the API logs, right, you can do it at the HTTP or like the REST APIs. Are there certain standards which you're seeing where, okay, this is how it's emerging in terms of how APIs are being logged? There's a log format and other things, standardizing it, right? So if you have thousands of different APIs, then they're all logging in different format, it's very difficult to go and.
So we're not actually looking at log data, we're looking at raw network traffic.
Yeah.
And so HTTP protocol is HTTP protocol, whether it's XML or JSON or some weird custom format. It doesn't matter if it's protobuf or GraphQL. What we're doing is just reading the HTTP layer. And then we understand those different formats, of course, so like you do need to be able to parse GraphQL to understand it, but we don't read logs for discovery. Is that what you're asking?
I was asking if you're familiar with any logging standard emerging at the. Because HTTP is obviously, if you look at network, you can figure it out. But if there's a better way to log it, so that we standardize all the API developers to, okay, log in this way.
I haven't seen anything. I've seen attempts, but it's similar to the, like if you've read the XKCD article about standards, every standard that comes out, someone figures out a better standard. So now you go from 11 to 12 standards. I don't know if I'm describing that very well, but yes, people keep putting standards out, but I'm not seeing something everyone's settling on. So I haven't seen anything in this space like that. So there are like common formats for like SEMs, like syslog and stuff like that, you'll push through your APIs to that, but even that, you have to do mapping to really make use of the data, so it's not.
And that's what I was asking. There's standards in other areas, so like for the system.
Part of the problem is like ask 10 developers what a REST API is, and you'll get 10 different answers. So, I mean, do you follow Helios or do you not follow Helios? It's like, you're laughing. I mean, it's thankfully some like emerging technologies, I say emerging, it's been around since what, 2007. Like GraphQL is very rigid how it's done. There's an RFC, there's a book, this is how you do GraphQL, REST doesn't really have that. So we are at least seeing better standardization there. But I haven't seen anything on the logging side. So.
Yeah. All these four stages sound very similar to the no-name API scan. Is that the same thing that you guys are talking for, or is it a different thing?
Sorry, for which piece?
All these four phases?
Yeah. Oh, it's all the
No-name API scan.
well, the no-name API product is what I say. It's
so is that plugged into any DevSecOps in any one of the clients that you have?
yeah, the testing side, so that would be what you would put in DevOps. That's like gas scanner. We have a few customers who have automated that process.
That's what I was.
It is, it's very difficult to automate. It's to be clear on, you have to have a really good process in place. you have to have gotten your developers to actually start creating specifications for your APIs.
The authorization
like
things
that.
are very hard to discover, right? Even if you have.
You have to have a process where they're providing authentication for the APIs, because if you're gonna do scanning, it's not, there's no point in doing scanning of an API if you're not authenticated to the API, because you're going to miss a lot of the issues.
More
So-
specifically the authorization, right? When the scanners are
You
there.
miss authorization, but you also miss things like data leakage. All you can get is a 404, a 401, a 400. You can't even detect something with data leakage ahead of time. So it's not a small challenge.
Still
to
a-
automate.
still a
We,
gap, right? I'm just asking a question, but.
yeah,
That's why it's still a gap, right? And like
It's still a gap.
It's kind of more kind of a hard rather than it's,
I would say that's probably true. Yeah. There's a finagling that goes into onboarding those into the tool. Yeah. I wish it was, oh yeah, just click the button, click, and you're done. No.
Okay.
Thank you. Yeah. We have a few customers who did it, but this was like, they were very dedicated to doing it. And complete coverage took them, I think, the one we're meeting with October 29th, we've got the QBR with them. It's what, 2 years now? Yeah, it took them about 2 years to get that done, so it's.
Yeah.
It's not a small project. It's a lot of work. Granted, they have, I think how many APIs did they have? Like 86,000 or something?
Yes, yes. It's, yeah, hundreds of thousands.
Like their security people are all software engineers, so even their security people are spinning up APIs.
Yeah.
So they've got a bit of a problem there.
it's a tough challenge to solve. Is
Yeah.
what I'm finding out,
Yeah.
from I'm from the application security side, when I see the APIs and all that stuff, there is no way that I can do a security peer review and capture all of that.
I do agree with the concept of shift left, where you need to do testing further left, but, and I understand why there's a view of, well, everything else is just cleaning up what's already out there. But your time to value on the discovery posture management runtime is going to be much higher, because one, it's already out there whether you start doing testing or not, so it's already in prod. And two, it's much easier to get at, much easier to automate, whereas testing is much harder to automate.
I have a question.
Yeah.
So, AI agents being deployed everywhere, they are being integrated with APIs. So, while these AI agents make these API calls, if there's a injection of things, is there anything like, let's say,
Guys, I hear a lot of other alternate discussions. If you're talking to the speaker, that's fine, but could you please hold off the parallel discussions? I cannot hear anything from this side. Thank you.
You're asking about like prompt injection.
prompt injection through AI agents, let's say the guardrails or the security risk measures that has to set for the AI agents to pay, and the prompt gets to the API call. So how is there any way or methodology to detect that?
So today, we're not doing that with the Akamai API security product. Instead, we have a firewall for AI product. And this is gonna kind of sound stupid, but it works. You put an LLM on top of your LLM, and you look at the prompts looking for a prompt injection before they get to the LLM. And that's what we're doing, and I haven't seen anything else that works yet. Unfortunately, LLMs are like, by their very nature, extremely insecure. I've seen attempts at like RAG model approaches where, well, if we make the API, the LLM access is really, really secure, then it'll be fine. And then you had a data leak because you had a Google Doc with wrong permissions on it. The AI found it and sped up the data. That doesn't help. So honestly, the only thing that we've really seen working for like prompt injection protection like that is just an LLM monitoring the LLM, which I don't know how many layers you can go there, because at some point someone's gonna figure out that's what people are doing, and they're gonna start putting prompt injections meant for the monitoring LLM. It's a really tough problem. If you figure it out, I think you'll have a very, very successful startup, so.
So Michael, we have 10 more minutes.
Okay, 10 more
Do you
minutes?
have any more slides or?
No, we can
Okay,
stop here.
yeah, there are some. Okay.
So
yeah.
your LLM on LLM, how are you addressing data?
So which aspect of data poisoning are you talking about with that? Like just,
Well, in general, you're gonna stack that on top of it. You actually source to be sure there's some control when you input that, top projection would be the input for one.
that's a good question. I think that would be a better question for a specialist on firewall AI, because I don't know the answer to that. Unfortunately, that's not a product that I looked at. Yeah, it's a fairly new product, I'll also say. We act like it's a new problem, although LLMs have kind of been around for a little while. It's just ChatGPT popularized it. It's not like they're actually that new, but we're seeing them everywhere, which is new. Good question. I'll have to ask.
They're in area of resources.
Yeah. I think, yeah. But
I was just curious because when we're discussing about the model poisoning attack on an API limits, right? So that actually does happen. Like that actually happens in industry. So my question is that, are you guys training your models on network logs?
no, we're training them on raw traffic. Like, think TCP dump type of raw traffic. Yeah, we train off of that.
So yeah, then that wouldn't more like you like something like an API based model poisoning attack. So that's when you don't know the content can be malicious. The training content for the model can be malicious.
Are you talking about like an LLM? Because we're not talking LLMs here. We don't use LLMs for that process.
Oh, okay.
Yeah,
Not today.
not today. Yeah.
Okay.
Firewall for AI, which is not a product that I've got a hold of, uses LLM, but API security does not use LLM. Take that for code scanning. Uses LLMs for that, which hopefully no one's putting, poisoning attacks in your code repos.
So when you say that, the network platform, you are referring to classic machine learning.
Yeah, classic machine learning, statistical analysis. I mean, what we call AI now was considered like classical machine learning at one point as well. It's just the name keeps shifting, and what's the new one there? Super intelligence is what they're calling it. I don't know, but at the end of the day, it's machine learning. I don't see any other hands. I think we can wrap up. Maybe. I think we're all complete here.
Thanks, Michael.